Hey guys, so instead of standing up at a board with a really badly lighted board and it's really blurry and hard to see, you're gonna get my disembodied voice, but it's okay because you're gonna be able to see a lot better. Oh, hi. You're gonna be able to see a lot better, because I'm gonna be using this sort of whiteboard thingy, for today's lesson. So we're gonna start out with a clarification. And the reason that we're doing that, the reason that we're starting out with a clarification is um because last week I talked about a lot of problems that we gone over, and I talked about one specifically that I wanted to clarify a little bit because it was one that really wanted us to look at proving um kind of proving the form for the idea of the reflection matrix, that ABB negative A form. And we started out, if you will recall, with this matrix. This was one that we knew because when we started to go prove that reflection theorem, the book gave it to us. And so we started out knowing that this was true, that this was the matrix that that this, could be turned into that form ABB negative A. But we want to prove that that's true. So the thing that I wasn't able to really fully articulate last week is that we know that these two things right here, as they're shown right here, are equal, right? We've got 2u squared minus 1 and 2u squared minus 1. Sorry if this 2 looks a little confusing, but it should be a squared. And so those two things are equal. But we know that the form we're trying to get to is a and negative a, right? So what does that mean? That means we have to prove that a equals negative a. What I mean by that is that we're going to have to take 2 u1 squared minus 1 and set that equal to 1 minus 2u squared and say that those two things are equal and solve from there. Well, let's look at why we have to do this, right? Because essentially, this is our a and this is our negative a. And to prove that the theorem ABB negative A works, we have to prove that A equals negative A because we see here that this equals this, right? So we have to prove that these two things are equal. So for the form ABB negative A to be true, A has to equal negative A. And so from there you would solve and you would get that these two are equal to each other. But that's the basic idea behind what you would do to prove this theorem true. The second part of the problem asks you to prove the a squared plus b squared equals 1 idea. And this part's pretty straightforward. I think I may have even covered it in the last video, but for the sake of full transparency, I will cover it again. What you would do here is that once we've proven that it's the ABB negative A form after all, this would be A, this would be A, and this would be B. So you would just do 2u1 squared minus 1 in parentheses squared plus b squared, which would be 2u1 u2 squared. Okay, so I really just wanted to go over that problem because I think it's really important. It's one that has to do with proofs, and I said that I would come back to it and explain it more fully. So that is that. But the next thing that we're going to do is talk about matrix multiplication. And when I say matrix multiplication, what I really mean is actually multiplying matrices together rather than matrices and vectors. But I'm going to put that in a separate video. So come back for another video that has to do with the next chapter.